Imagine looking up at the night sky, the familiar darkness above you sprinkled with countless stars, each one a distant sun. For millennia, humans have gazed upward, wondering about the mysteries hidden in the cosmos. But what if instead of just one sun, you saw two brilliant orbs lighting up the horizon? A world where sunsets are double, and shadows stretch in unexpected directions. It sounds like something out of science fiction, but let's explore what would happen if Jupiter, the giant of our solar system, suddenly ignited and became a star. Jupiter is a true behemoth, with swirling clouds and storms larger than Earth itself. Deep within, its core is crushed by unimaginable pressures and heated to temperatures hotter than the surface of our sun. Despite its size, Jupiter is often called a failed star. It simply doesn't have enough mass to ignite the nuclear fusion that makes stars shine. Fusion is the engine of the stars, fusing hydrogen into helium and releasing vast amounts of energy. If Jupiter were about 80 times more massive, it would cross the threshold needed for fusion, blazing to life as a new star in our sky. Imagine a cosmic accident. Jupiter somehow gains enough mass, maybe by colliding with wandering planets or devouring wayward asteroids, growing ever larger with each encounter. Or perhaps it sweeps up vast clouds of interstellar gas, gathering the raw material needed to tip the balance and spark a transformation. Eventually, Jupiter's core would reach the critical temperature and pressure for nuclear fusion. In a sudden, spectacular burst, a new star would be born right in our solar system. The ignition would be a cataclysmic event, transforming Jupiter into a red dwarf, a small, dim star compared to our sun, but a star nonetheless. Red dwarfs are the most common type of star in the universe. They burn cooler and live far longer than stars like our sun, quietly shining for trillions of years. Even as a faint star, Jupiter, now Sol B, would radiate its own energy, casting a gentle glow and subtle warmth across the solar system, forever altering the balance of light and heat. Our familiar solar system would become a binary star system, joining the ranks of countless others in the galaxy, where two stars dance together, shaping the destinies of their planets. The rules of our cosmic neighborhood would be rewritten. Orbits would shift, climates would change, and the very definition of a year could be transformed. The solar system would be forever changed, bathed in the glow of two suns. Days and nights would become more complex and the skies would never look the same. Day and night cycles, gravity, and the fate of every planet and moon would be transformed in ways we can only begin to imagine. The age of a single sun would be over, and a new era of cosmic wonder would begin. How could Jupiter actually ignite? It's a question that sounds like pure science fiction, but it's rooted in the real physics of stars and planets. Jupiter, the largest planet in our solar system, is often called a failed star. But what would it actually take to turn that nickname into reality? It's all about reaching a critical mass. Just like stacking rocks higher and higher, there's a tipping point where the weight becomes enough to trigger something extraordinary. To trigger fusion, the process that powers stars, Jupiter's core would need to hit about 15 million degrees Celsius. That's far, far hotter than its current state, which is only a fraction of that temperature. Right now, Jupiter glows faintly in infrared, but it's nowhere near the threshold for true starlight. The only way to get there is to add mass, lots of it. We're talking about a cosmic scale of accumulation, far beyond anything we could ever achieve with technology. Imagine merging 79 more Jupiters together. That's the kind of mass needed to push Jupiter over the edge, transforming it from a gas giant into a true star. While impossible for us, cosmic accidents do happen. The universe is full of collisions and mergers, some so violent they reshape entire solar systems. A wandering brown dwarf, a failed star itself, could collide with Jupiter, pushing it over the threshold. Such an event would be rare, but not outside the realm of possibility in the vastness of space. The moment fusion begins, Jupiter would shrink and shine, not with the sun's brilliance, but with a soft reddish glow. It would become a red dwarf, the smallest and coolest kind of star. As a red dwarf, Jupiter Sol B would be faint but incredibly long-lived, burning steadily for trillions of years, far longer than our sun will last. From Earth it would appear as a bright red star, never as dazzling as our sun, but unmistakable in the night sky. It would change the way we see our own solar system forever. The birth of this second sun would be sudden and disruptive, sending shockwaves through the solar system. But after the chaos, its presence would be stable for eons, a new fixture in our cosmic neighborhood. The solar system would settle into a new equilibrium, with two stars beating at different rhythms. Planets would adjust their orbits, and the balance of light and gravity would shift. Red dwarfs are the marathon runners of the cosmos, outlasting stars like our sun by orders of magnitude. While our sun will eventually fade, a red dwarf could shine on for trillions of years, a slow-burning ember in the darkness. The initial chaos would give way to a new kind of order. Over time, the planets and moons would find new paths, and the solar system would become a binary star system. Life, if it survived the upheaval, would have to adapt to a solar system with two hearts. Plants and animals might evolve to use the new red light, or find ways to thrive in the changed environment. The binary system would actually be more common than our current arrangement. Most stars in the galaxy have companions, making our single-sun system the exception, not the rule. The solar system's lifespan would be extended, but its conditions for life would be forever changed. The climate, the seasons, and even the colors of the sky could shift in ways we can only imagine. The age of a single sun would be a memory replaced by a new era, one where two stars share the sky and the story of our solar system takes a dramatic new turn. With a second, dimmer sun, true darkness would vanish from Earth. When our sun sets, Jupiter Sol B's reddish light would rise, bathing the world in perpetual twilight. The night sky would be washed out, only the brightest stars would remain visible. Life's rhythms, evolved over billions of years of day and night, would be thrown into chaos. Nocturnal animals would lose their darkness, and plants' biological clocks would be disrupted. Jupiter's 12-year orbit would create cycles of warming and cooling, overlaying our seasons. The world would glow with a crimson hue, and sunrises and sunsets would become spectacular, mixing the light of two suns. Our sky would be a dynamic, ever-changing display, a constant reminder of our new reality. The age of true night would be over. The arrival of a second sun would raise Earth's temperature dramatically. Even a faint red dwarf would add enough energy to push our planet out of the habitable zone. Ice caps would melt, sea levels would rise, and coastal cities would vanish. Weather would become extreme. Supercharged storms, floods, and droughts would sweep the globe. The stable climate that nurtured civilization would be replaced by chaos. More water vapor would trap even more heat, risking a runaway greenhouse effect. Earth could become a hothouse more like Venus than the blue world we know. The age of a temperate Earth would end. Life is resilient, but a second sun would push it to the brink. The relentless heat and constant daylight would transform every corner of the planet, challenging even the hardiest forms of life to adapt or perish. Mass extinction would sweep the planet, species adapted to darkness or cool climates would vanish. The delicate balance that sustains ecosystems would collapse, leaving only the most adaptable survivors. Nocturnal animals and polar creatures would be among the first to go. Their habitats would disappear, and their unique adaptations would become useless in a world of endless sunlight and rising temperatures. Some life would thrive. Thermophiles and heat-loving microbes would expand their domain. These tiny survivors would colonize new, overheated environments, becoming the dominant life forms in places once inhospitable. Plants adapted to heat and aridity might take over, while forests and grasslands would shrink. Deserts would spread, and only the toughest, most drought-resistant species would survive the relentless sun. Oceans would develop dead zones as oxygen levels dropped. Coral reefs would disappear. Marine life would struggle as rising temperatures and toxic algae blooms suffocate the seas. Algae blooms could dominate, suffocating marine life. The once vibrant underwater world would become a shadow of its former self, with only the simplest organisms able to survive. Over millions of years, evolution might produce new, heat-adapted species, reflective skins, new pigments, and underground habitats. Life would innovate, finding ways to cope with the extreme environment, but the process would be slow and filled with setbacks. But Earth's diversity would be shattered, and the age of mammals and humans would likely end. Civilization as we know it would be lost, leaving behind only traces of what once was. Life would find a way, but the world would be unrecognizable. The planet would be transformed into a strange alien landscape, shaped by the relentless energy of two suns. The age of complex life would be in jeopardy. In this harsh new world, survival would belong to the few, and the story of life on Earth would enter a dramatic, uncertain new chapter. Jupiter's transformation would unleash gravitational chaos. With 80 times its current mass, Jupiter Sol B would become a co-equal partner with the Sun. Both stars would orbit a common center, destabilizing planetary orbits. The inner planets could be flung into eccentric paths, risking collisions or ejection from the solar system. Saturn and the outer planets would be pulled into new, unstable orbits. Moons could be lost or sent wandering. The solar system's familiar order would dissolve into chaos. The clockwork of the heavens would be shattered. Life's long-term prospects would dim as the system became unpredictable and dangerous. The age of stability would be gone. Jupiter currently shields Earth from many asteroids, but as a star, it would do the opposite. Its increased gravity would disrupt the asteroid belt, sending countless rocks hurtling inward. Earth would face a barrage of impacts, with catastrophic consequences. Major asteroid strikes would trigger earthquakes, tsunamis, and global winters. The Oort cloud's comets would also be disturbed, sending icy bodies plunging toward the inner solar system. The era of relative peace would end. The solar system would become a shooting gallery. Survival would be a matter of luck. The age of cosmic safety would be over. The threat from above would be constant. The familiar calm of our skies would vanish. Amid the chaos, the sky would be a source of wonder and awe. By day, the sun would shine, but Jupiter Sol B would glow as a brilliant reddish star, even visible at noon. Nights would be filled with a ruddy twilight, making stargazing nearly impossible. Eclipses would become more frequent and complex, with the moon and planets casting shadows on both suns. Celestial alignments would create breathtaking spectacles, double sunsets, overlapping eclipses, and new constellations. Humanity would invent new myths, art, and calendars to make sense of the ever-changing sky. The sky would inspire, even as it reminded us of our vulnerability. Our relationship with the cosmos would be forever changed. The age of a simple sky would be gone. Wonder and fear would share the heavens. The story of the stars would be rewritten. What if Jupiter became a second sun? The result would be catastrophic. A world transformed beyond recognition. Earth's climate, life, and place in the cosmos would be upended. The solar system's stability would shatter and survival would be uncertain. The beauty of two suns would mask a nightmare of chaos and extinction. Yet, this thought experiment reminds us how delicate our cosmic balance is. Jupiter, as a gas giant, is not a failed star, it's our protector. We should be grateful for our single sun and the stability it brings. The age of one sun is the age that made life possible.